Hamza, am I audible?
Yes, sir.
So I'm gonna give you some question on acid and bases. In the previous class, we didn't do any question on acid and bases. So you need to tell me which you need to arrange the followings in acidic and basic character as well. So the first one is acidic. There is OH and there is chlorine, acidic acid. And I think you can do this. Which one is most acidic? So whenever we are going to calculate acidic character, what you need to keep in mind is acidic strength or acidic character directly proportional to minus I, which is directly proportional to minus R minus M. That means the compound of substance in which more but here it is fluorine, cyanide, and NO2, in which NO2 has the powerful withdrawing power. So which one will be the most acidic? NO2 and then CN, and it is the this is oh my, here it is your cyanide, and this is your O negative, and here it is your anode. Now tell me which one will be the most acidic. Hmm. And I think you can do this easily. Priyadarshini, is there any answer from you? Adriel, any answer? Very good. Priya, any answer from you? Which one will be the most acidic? You can see this again will be followed, but here you can see the position is changed. That means you need to do distance. So here distance will dominate over power. I told you about DNP rule. DNP rule. Distance will dominate over number and number will dominate over power. That's why fluorine will be the most acidic here and CN and NO2. Is that clear to all of you? Aditya, can I change the slide?
Sir, can you repeat your voice was lagging?
Adriel, Priya, and Aditya, why are you not responding at all? So whenever my voice is lagging, just let me know. Adriel, see. In this, you can see fluorine has the fluorine is if you are going to see the withdrawing power among fluorine, cyanide, and NO2. NO2 will the having the most withdrawing power, then CN, and then comes fluorine. And you know that acidic is directly proportional to minus I and minus R. So in this, you can see the position. That means the position with respect to OH is same. That's why NO2 is the highest acidic or more acidic strength. But in the second case or in the second question, you can see CN is far away from this group. That's why if the distance increases, the withdrawing power increases. So here I told you about DNP rule. Distance dominates over number and number dominates over power. So if distance increases, the power will decrease. That's why fluorine here will be the most acidic because it is nearer to this group with respect to this group, and it can easily withdraw electron from this group as compared to CN and NO2. That's why in this case, this group or this compound will be more acidic. Is that clear? Adriel,
Yes,
Hamza,
yes, sir.
Hamza, you gave me the answer. Uh, Priya and Aditya. So in JEE mains, just keep it in mind that at least you will get 2 to 3 questions. At my time, there was 4 questions from GOC, and it was sorry, I just got this. Am I audible?
Yes, sir.
Okay, so I was saying that this GOC is very important for JEE mains and as well as for other chapters of organic chemistry. At my time, there was 4 questions from GOC, and it was all about acidic character, basic character, and stability. And this stability, acidic character, basic character will be solved uh, only if you know about inductive effect, resonance, and hyperconjugation. These 3 topics is very important in GOC. And you know that anti aromatic and anti aromatic and non aromatic, these are very very important. So please be careful and also please do solve questions from PYQs previous years. Which one is more acidic? Very good, very good. A will be more acidic because number dominates over power does. Hmm. Okay, please do. This was correct. Please do this first. This is your carbocation here, and then the carbocation here, and then the carbocation here. Is there any answer? Which one is more stable? Not, I'm not asking about uh, acidic character. I'm asking about stability. Which one is more stable? Aditya, Hamza, Adriel, Priya, any answer? So you can see this is electron deficient and it is 1 degree. This is your 3 degree and this is your 2 degree. That means this will get support from two sides, this will get support from three sides, and this will get support from only one side. That's why 3 degrees more stable than 2 degree. That means T and then 1. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay. Okay. So you have studied about what we say um, aromatic, non-aromatic, and anti-aromatic. I want you to solve this first. Which one is aromatic? Which one is non-aromatic? You can give me the answer. You have got 4 minutes. Please do this. Aromatic and anti-aromatic and non-aromatic. As you have already studied about this, to check the aromaticity of any compound, you have four conditions. The first one is it should be cyclic. The second one is it should be planar. The third one is the electrons or the pi electrons should be in conjugation, complete conjugation of the ring. And the fifth one is Huckel rule. If you got 4n plus 2 pi electron, you will get aromatic compound. And if you will get 4n pi electron, that means electrons of the multiple 4, then it is anti-aromatic. And in any one of these four rules fail, then it is non-aromatic. This is a how wrong. Non-aromatic. Non-aromatic. If any one of them fails, then it is non-aromatic. Only the between aromatic and anti-aromatic, there is only one difference, the Huckel rule, 4n plus 2 pi electron. That means 2 pi electron, 6 pi electron, 10 pi electron, 14 pi electron. And for anti-aromatic, it is 4 pi electron, 8 pi electron, 12 pi electron. So please do let me know about this. If you still don't get it, please do let me know. I'll explain about this. Any answer for the second one? No, Adriel, you have to check whether it is cyclic. Yes, it is cyclic. Then check the planarity. Planarity, for planarity, the carbon should be either sp hybridization or sp2 hybridization. This is your sp2 and this is also your sp2. But this is your sp3 that represents, and this is also your sp3 that represents it is not planar. It is tetrahedral, and that's why it is not planar. So it is also non-aromatic. What it is? It is non-aromatic. If any one of the four rules fail, then it is non-aromatic. Is that clear, Adriel? Hamza, you have to check the cycle, whether it is cyclic or not, then planarity, then you have to check the conjugation, whether the conjugation is in complete ring or not. Am I audible to all of you? Sorry, I just got disconnected due to uh, protest in my area. The electricity is went off on 17th March, so there is some problem. I hope you will understand. Are you able to solve the question number third? Yes or no? Aditya, are you able to solve the question number third? Adriel, am I audible to all of you? Aditya,
Yes, sir.
Yes, sir.
okay. Are you able to solve the question number third? Please interact with me so that I will be able to understand whether you are getting it or not. If you are not getting the point of this aromaticity, I will explain it in other way. Anyone have got this answer? See, the compound is cyclic. Yes, it is cyclic. The compound has planarity. You need to check the hybridization. And since every carbon in this benzene ring have is making double bond, that means all are sp2. That means planar it is. Then check the whole conjugation. That means you can see pi sigma, sorry, pi sigma, pi sigma, pi sigma, and then pi. That means conjugation is there. So conjugation is there. Then count the number of pi electrons. How many pi bond is there? 3. So pi electron is 6 pi electron, and you can see 6 pi electron comes in this aromatic. So it is aromatic compound. I think it's clear to all of you. It is aromatic compound. Yes or no? Think
Yes,
about
sir.
see what about this? It is cyclic. You just need to focus on the cycle or the ring, not outside the cycle. Planar it is. You can see every carbon in this benzene ring making double bond. That's why it is sp2, and hence it is planar. And you can see pi sigma, pi sigma, pi sigma. That means conjugation is also there. And then you can count the pi electron, and pi electron is in the ring. 3 pi bond is there, so 6 pi electron is there. That's why it is also aromatic. Now come to this. It is cyclic. Yes, it is cyclic. Whether it is planar or not, it is planar because this two carbon is having double bond. That means sp2, sp2, and this positive represent that it is carbocation. Carbocation has sp2 hybridization. That means it is planar. Then come for conjugation. Conjugation is also there. You can see that this is your pi bond, sigma bond, and vacant orbital. Again, pi bond, sigma bond, and vacant orbital. That means it is conjugation. Then go for Huckel rule. You can see only one pi bond is there. That means 2 pi electron. That means 2 pi electron, and 2 pi electron comes under aromatic. That means this compound is aromatic. Now go for this compound. You can see it is cyclic. Yes, it is cyclic. Whether it is planar or not, it is planar. This is very important compound. This is very important compound. Don't count this negative charge in. Don't count this negative charge don't take it as lone pair and count it in hybridization. This carbon is sp2 because this negative charge in conjugation, and that's why it is pi electron, and we don't count pi bond or pi electron in hybridization. This is your pi, sigma, and negative charge. This is in conjugation, and you can see cyclic planar conjugation. I already told you, and then go for Huckel rule. You can see this is the pi electron, that is 2, and this is also pi electron. This is delocalized. It will also, it is in conjugation with the pi bond. That's why it will be, you can see this will come here and this will go here. That means this is also pi electron. Electron, 2 delocalized electron, 4 pi electron. That's why this compound is anti-aromatic. This compound is anti-aromatic. You can also go for this. This is your localized. That means it is not pi electron, but this is delocalized. This is delocalized. So this, you can see cyclic, you can see planar, you can see conjugation like pi, sigma, and then this lone pair. Then pi, sigma, lone pair. Pi, sigma, pi. And you can also count the pi electron. You can see 2 pi bond and 1 lone pair, that represents 6 pi electron. That means this is aromatic. Then come for this. This is also aromatic. You can see only 2 pi electron is there, planar is there, planarity is there, cyclic it is, and conjugation is also there. That's why it is aromatic. That's why it is aromatic. Then come for this compound. Planarity, this is anti-aromatic. You can see 4 pi electron is there. 4 pi electron. 2 pi bond, 4 pi electron. Planarity is there, cyclic, conjugation, and then 4 pi electron. That's why it is anti-aromatic. Is that clear to all of you? Or you are still facing problem with this?
So can you explain sixth one again? The pi electrons.
This one?
Six, yes, sir.
Okay, let me draw it at other place, and then I'll. That's a good question. Now see, this was the scenario, right? This was the scenario. Okay. Now, if you want to check whether it is aromatic, whether it has aromaticity or not, first of all, cyclic it is. That's good. Then planar or not, planarity or not, planar or not. So you can see this is your sp2, and this is also your sp2. This is also your sp2. But generally, students do what? They take it as sp3 because you have seen in ESP negative, this is sp3. 3 sigma bond, 1 negative charge, that means lone pair sp3. But it is not. Why? Why it is so? You know that hybridization has a basic formula. Hybridization is equal to sigma bond plus lone pair or negative charge. But here, this negative charge is in conjugation with this pi bond. That means pi, sigma, and then negative charge. That means if it is in conjugation, that means it can be pi bond again. It will take part in resonance. So you can see this will move to this and this will move to this. So you can see that there will be negative charge, and this negative charge becomes sigma bond. That means this negative charge is pi electron, not sigma electron. Sigma electrons, that means sigma lone pair, that will take part in hybridization, but pi does not take. So that's why this is your sp2, and hence it is planar. Then come for conjugation. You can see it is conjugation pi, sigma, negative charge, pi, sigma, negative charge. You can also take it like this, pi, sigma, negative charge. That means conjugation is also there. Conjugation is also there. Then you count the number of pi electrons. 1 pi bond is there, that means 2 pi electron. And you can see this negative charge is also pi pi electron because it is delocalized. Delocalized, that means it can form pi bond. It will be pi bond after drawing the resonating structure. You can see. So 2 pi electron, it becomes 4 pi electron, and 4 pi electrons come in anti-aromatic. That's why this compound is anti-aromatic. While solving the another question for this, you can see this was positive, and this is your aromatic because it is cyclic. Planarity because sp2, conjugation is there, and 2 pi electron is there. That's why it is aromatic. Is that clear to everyone? Please do respond.
Yes, sir.
Okay.
Yes.
Okay. Does anyone have any doubt in this aromatic compound? Where it is? Wait a minute. Yeah, in this. If anyone have any doubt, please ask me right now.
So can you explain the ninth one?
Ninth one, I will. Sorry, I again got this. Am I audible clearly?
Yes, sir.
Okay, thank you. So I was going to explain this all. Are you able to see the screen, right, everyone? Now see.
Yes, sir.
First of all, check the whether the compound is cyclic. You can see it is cyclic. For planarity, you need to check the hybridization. This is sp2. This is also sp2. All are sp2 hybridization. That means it is planar. Then go for conjugation. Conjugation, you can go for conjugation. You can see uh, pi sigma vacant orbital, pi sigma vacant orbital, pi sigma pi. These are all in conjugation. Then go for Huckel rule. Huckel rule, that means you need to count the pi electron. How many pi bond is there? 2 pi bond. That means 4 pi electron, and 4 pi electron comes in anti-aromatic. That's why it is anti-aromatic. Ideal, Aditya, Priya, and Hamza. Everyone got it?
Yes,
Yes,
sir.
sir.
Okay. Is there any other question regarding this aromatic and non-aromatic? You don't need to think about the group outside the ring. Only you need to think about inside the cyclic. Is that clear?
Yes, sir. Clear.
Yes.
Okay. Can we move to the next part? That is aromatic compound. Today we are going to start this aromatic compound. What is aromatic compound? We already know. The first one is it should be cyclic, planar, the compound should be moving, and then Huckel rule. That means since we are talking about aromatic compound. That means here the Huckel rule only about this 4n plus 2 pi electron. That means basically you should have either 2 pi electron, you should have either 6 pi electron, you should have either 10 pi electron, you should have either 14 pi electron, and so on and so on. Basically, in this aromatic compound, we will only deal with the compound like benzene. We will only deal with benzene or benzene-like structure. That means derivative of benzene. Like if you want to see, this will be the scenario. This is your benzene. This is your benzene. Or either we will talk about methyl benzene. That means methyl benzene. That means its common name is toluene. Its common name is toluene or methyl benzene. It's IUPAC name, and this is your benzene. So first of all, in this aromatic compound, in every chapter of the this isomerism and GOC, we will deal with the preparation of the compound and physical properties of that compound. So I'm gonna start this aromatic compound, and here my first topic is methods of preparation of aromatic hydrocarbon. Method MOP, I'm gonna write it directly MOP. That means MOP stands for method of preparation of aromatic hydrocarbon. Aromatic hydrocarbon. Can anyone tell me what is hydrocarbon? What do you understand by this term hydrocarbon? Anyone? What does hydrocarbon mean? Hydrocarbon, that means a compound which contains only carbon and hydrogen, that is called your hydrocarbon. Apart or other than hydrogen and carbon, if there is anything else like oxygen, nitrogen, or sulfur, then it is called hydrocarbon derivative. So basically, we are here going to do the preparation of benzene. Preparation of benzene. So I'm going to write it in a single way. It's very easy. See, please do write with me this reaction. This is your benzene, and how I am going to prepare it from there are how many ways? 1, 2, 3, 4, 5, 6, 7. So the first preparation is from benzene wait a minute, benzene hexachloride. Just write with me, please. What is benzene hexachloride? This is your benzene hexachloride. I will write all the name of it. This is your disonium. Then comes your benzene sulfonic acid, SO3H. Then comes your benzoic acid. You have seen all these compounds in class 12. Then comes your phenol. Then comes your 1, 2, 3, 4, 5, 6. And hexane, normal hexane. Then comes your HC triple bond. Okay, HC triple bond. First of all, write it and then I'll explain. And out of these 7, you only study three of the out of seven in class 11, but all the four reaction you have studied it in class 12. So it won't be difficult for you to understand. Okay. Just let me know when you are done with it. Are you done with this?
1 minute, sir.
Okay, okay. Take your time. Thank you for the reply. Please do respond like yeah.
Done, sir.
Done it. Okay. So first of all, I'm gonna concentrate on the reaction that you have already studied. So you know that this is benzene diazonium salt, and it is a redox reaction. Benzene diazonium, it is benzene diazonium, and if there will be Cl minus, that is benzene diazonium chloride, that is also known as salt. So this is your BDS, and how you are going to remove the nitrogen, you just need to use a reducing agent, that is H3PO2, or either you can use ethanol, because these both will be reacting as reducing agent, and it will remove this nitrogen in the form of N2, and you will get benzene. The second one is SO3H, and for SO3H, what you need to do, just pass this or mix it with warm H2O, or you can either use dilute H2SO4, dilute H2SO4. This SO3H will be vanished or removed by this compound, and you will get again benzene. This is your benzoic acid, and this reaction is also from class 11th as well as 12th. We will use soda lime. We will use soda lime. What is soda lime? Soda lime is basically mixture of NaOH plus CaO. What it will do, it will remove this CO2 in the form of CO2, that will be basically Na2CO3 or CaCO3, and then you will get again benzene. The next one is OH. If you have studied alcohol phenol sandifer, this reaction is near to the Riemer-Timmins reaction, in which you are going to use zinc dust, and what will happen? This zinc will reduce this phenol. That means it will take oxygen, and you will get this benzene. This four reaction you have already studied it in class 12. Now this is your N-hexane. This is your N-hexane. Now, what you need to do, if you want to prepare a benzene from N-hexane, this N-hexane will be treated with this reaction. This reagent is very important. Either you can use Cr2O3, either you can use Al2O3, either you can use B2O5, either you can use MO2O3, or at 10 atm pressure and 773 Kelvin, this N-hexane will be converted into benzene ring. Then this N-hexane will be converted into benzene ring. Now, from alkyne or ethine, how you are going to prepare? It's very easy. You can see I'm gonna write it here: CH triple bond CH. Then I'm gonna write it here: CH triple bond CH, and then I'm gonna write here CH triple bond CH. What will happen if you are going to pass this through red hot iron at red hot iron tube at 1073 Kelvin, 1073 Kelvin, then this will primerize with each other and then forms benzene. The last one, which is very important, and this is known as gamaxene. This is also known as, this compound is also known as gamaxene or lindane. We also call it lindane, or we used to call it triple six, or BHC. BHC stands for benzene hexachloride. This is not a benzene, but its common name is benzene hexachloride. It's not benzene. You can see there is no there is no pi bond, but its common name is benzene hexachloride, and you are going to react this with zinc dust. What will this zinc do? This zinc will take two chlorine from this zinc will come like this, and it will take this chlorine out. Then this zinc will also come here, and it will take out. This zinc will also come here, and it will take out chlorine, and there will be double bond between this carbon and this carbon, and then this carbon and this carbon, and then this carbon and this carbon. And here how we prepare the benzene. These seven reactions are very important. To do very good in organic chemistry, you need to remember the reagent, only not the name of the reagent. You have to also remember what actually it do. What does it mean basically? What is the function of this reagent, whether it is reducing, oxidizing, bond cleavage, bond breaking, all this. So please do write this. We just finished the preparation of benzene. Let me know when you are done with. Does everyone have JEE Mains previous year's question? The book that contains JEE Mains previous year's question.
Yes, sir.
Priya, Adriel,
Yes, sir.
very good. Hmm. Let me know when you are done with it. Very good. I'm gonna change the slide and I'm gonna give you a question on this. So can you do this reaction? You need to convert this into toluene. Please do it. Very good, Adriel. To convert this, you can see 4-methylbenzene or paramethylphenol, sorry, paramethylphenol into toluene. That means methylbenzene. You just need to use zinc dust. What will zinc dust do? Will do? This will remove oxygen and it will be converted into toluene. And for this SO3H, either you can use warm H2O or either you can use dilute H2SO4 and this will be converted into toluene. This SO3 will be removed and this will what you will get. Is that clear?
Yes, sir.
Okay. So you have studied about the HBr reaction, Markovnikov and anti-Markovnikov. Do you remember?
Yes, sir.
Right, a topic, chemical. Oh, wait a minute, please. Chemical properties. Of aromatic hydrocarbon. Aromatic hydrocarbon. So you can see if you have a benzene ring like this, and if you are going to react this with the HBr, that means electrophilic addition reaction. So what will happen? Basically, one of the double bond will be broken, and this is what you will get. The rest bond will be as it is. Hydrogen will be added, and bromine will be added. But you can see that here it is aromatic compound. But after having this reaction with HBr, this is a small r, not capital R. Bromine it is. Aromaticity loss, aromaticity loss. So due to, you can see this is more stable, this is less stable. That's why this reaction will not take place. Every compound in this universe wants to be stabilized. So aromatic hydrocarbon, you can see this aromatic hydrocarbon, due to this reaction, it loses its stability. That's why this reaction will not take place. And you can say aromatic hydrocarbon does not give P plus addition reaction. That means electrophilic addition reaction. Because of this reaction, it loses stability. That's why it will not give this reaction. Is that clear? Electrophilic
Yes, sir.
addition reaction it will not give because aromaticity will be lost and that's why it will not give this. Can I change the slide? Please do write it. You can either write it here. This is very important. Again, I got disconnected. So this is very important. Aromatic hydrocarbon will not give electrophilic addition reaction aromaticity. Please do write it. If you are done with this, just let me know. We'll move to the next topic. next type of reaction. Can I change the slide?
Yes, sir.
Okay. Now, but aromatic hydrocarbon do give the reaction of this, what we call electrophilic addition reaction, not addition, substitution reaction. So here it can easily give electrophilic substitution reaction. Now you can see the reaction here. It is benzene like this. And benzene in each carbon will possess hydrogen. So what will happen here? I am going to write the reaction directly, and then you will easily understand. This is your electrophile. Since it is electrophilic substitution reaction, that means in this reagent will have an electrophile, and then there is a base B negative. So what will happen here? In one step, I can explain it like that. This hydrogen will go with this base, and this electrophile will replace this hydrogen. And with this help, you can see the aromaticity is also not lost, and this BH will be byproduct. So electrophilic substitution reaction is possible here. We can see the mechanism, how does this reaction took place. You can see this is your benzene ring. This is your benzene ring. Wait a minute. This is your benzene ring. I'm gonna write it like this. And if this is your benzene ring, and you have an electrophile, you have an electrophile. So what will do? This double bond or alkene will attack here. This alkene will attack here, and this has already hydrogen, and you can see that this this alkene double bond will attack here, so there will be hydrogen as well as this is electrophile. This will go there, and there will be positive. Basically, the bond of this bond is heterolytically cleaved. That means it has two electrons, and this carbon will take the both electron like this. So there is negative charge. So this electrophile will go to this carbon, and there is positive charge on this. Now, what will happen here? In the second step, base will come, and this base will attack on that hydrogen, and this hydrogen's carbon bond will be converted into double bond in this. And first, it loses its aromaticity, then again, it gained its aromaticity, and that's why electrophilic substitution reaction is possible in aromatic hydrocarbon. Also, remember that this is your lowest step, and this is your RDS, rate determining step. Since it is losing its what its aromaticity, that's why it is slow step, and since it's gaining its aromaticity towards a stability, that's why it is faster. And in the reaction, whichever is the slow step, that is rate determining step. Please do write it. So electrophilic substitution reaction is very important. Please do it. Everyone done with this?
Yes, sir.
Yes, sir.
Now, this electrophilic substitution reaction, you have studied about nitration, you have studied about halogenation, you have studied about Friedel-Crafts alkylation. Alkylation, that means you are going to add alkyl group. Nitration, that means you are going to add nitro group. There will be NO2 plus nitronium electrophile that will be attacking on that. So I'm going to show you. There is a benzene ring. Write with me, please. This is your benzene. In a single reaction, we will complete this. Wait, this is the reaction. If you are going to use concentrated HNO3 plus concentrated H2SO, and then heat as what will happen. Then there is another way that is, write with me, please. X2 plus ALX3 and heat. Then comes the next reaction, that is concentrated H2SO4. Then comes the next reaction, RH alkyl halide plus anhydride AlCl3 and then comes the last reaction, plus anhydride AlX3 or AlCl3. So focus here now. Please stop writing. Here you can see concentrated HNO3 and concentrated H2SO4. Due to this, there will be generation of a nucleophile that is NO2 plus nitronium ion. And since you can see in the previous question, previous concept, electrophile E attacked on any position of the benzene you can attack. So in this way, you can see this electrophile will be added on benzene. And X2ALX3. This is basically formation. There will be formation of a what we say electrophile that is X plus. That is X plus. So here it will be addition of this. I'm going to show you. This is the addition. X will be attacked on any position of the benzene. And here there will be formation of SO3 plus. SO3. SO3. This is the electrophile. So it will attack on the benzene in this SO3. It will. Now there will be a formation of an electrophile that is R plus. So this will be the product. Now there will be formation of an electrophile that is RC double bond O positive. So this will also attack on the benzene, and this will be. Now, as you can see, we added nitro group. So this reaction, you have heard about this. This is your nitrate. Since we are adding X, so this is your halogenous. Since we are adding SO3H sulfonic acid, so this is your sulfonase. Sulfonase. Since we are adding R, so this is your Friedel-Crafts alkylation. Name of the scientist, Friedel-Crafts alkylation. And this is your Friedel-Crafts acylation. Acyl halide is added, so this is your Friedel-Crafts acylation. So it's very easy. Nitrate halogenation, sulfonation, Friedel-Crafts, alkylation, Friedel-Crafts, acylation, and very important as well. Please do right. If there is any group on the benzene already there in the reactant, with respect to that group, we generally do add this on ortho and para. On ortho and para. So I'm going to give you a question on that. And if the group is minus M, that means it is meta directing. That means the coming group or the electrophile will be adding on meta. And if it is plus M, then definitely it is para and ortho directing. That means electrophile will go at para and ortho. And para generally is more stable than ortho because ortho is nearer to with respect to group, and it will be a steric handprints. That's it. Please do write it. Let me know when you are done with it. So I just covered all the reaction, electrophilic substitution reaction of benzene or aromatic. Everyone done with this?
Yes.
Okay, very good. Now I'm gonna give you a question on this. Basically, this is your homework. Same question is there, only a group I'm going to add. Basically, the previous question was based upon only benzene, and I'm going to attach the group in benzene that is toluene. I'm going to attach CH3. This is your toluene. The first reaction is similar. Concentrated HNO3 plus concentrated H2SO4. Please do write this question, and this is your homework. Then comes your second, X2 plus AlX3, and then heat. Then comes the third, that is concentrated H2SO4. Then comes the fourth, RH plus anhydride AlCl3 and heat. Then comes the next one, RC double bond OH plus again anhydride AlCl3 or AlX3. I'm gonna put it here because I have to take care. So there will be two products with respect to this. Either it will be on ortho and either it will be on para, and para will be more stable. I'm going to give you an example. So there are two products with here. We will get an electrophile NO2 plus, and with respect to this CH3, this will be added at ortho, and this can be also added at para. So basically, you can see there will be a steric hindrance between this and this group. So this will be your major group, and you have to do the rest. No, no, not at so if it is a nucleophile, it will be added. Okay, if there will be a nucleophile, so why it will be added on meta position? That depends on basically which group is here added, which group is added here. Like if you have taken CHO, that is aldehyde, and if you have a nucleophile, that will definitely attack on meta. And if it is OH group, that means plus M effect, that will attack on ortho and para only. Are you getting my point? Adriel?
Yes, sir.
Okay, it's your question. Please do write this question. Everyone has uh, written this question. Done with this question. Then I move to the next.
Done, sir.
Very good. Now the next question I'm going to give you. This is your benzene. And if you are going to react this benzene with 3 mole of H2 and nickel and going to give heat or HNO, then let me know the product. And if you have this Cl2 HNO in excess, then what will happen? And if you are going to react this with Cl2 plus AlCl3 heat in excess, and if you are going to react this with KMNO4, which is a strong oxidizing agent, KMNO, a strong oxidizing. So, this is the hydrogenation reaction. And what will happen? The bond between carbon-carbon will be broken. That means an unsaturated hydrocarbon will be converted into saturated hydrocarbon. This is the first use. Cl2HNU in the excess. That means basically this will be converted into gamma-hexane. BH3, benzene hexachloride, if you remember, this will be converted into benzene hexachloride. So this will be scenario. This is your gamma-hexane. Gamma-hexane. Now the next you can see Cl2 in the presence of AlCl3. There will be generation of an electrophile that is Cl plus, and it will attack on, since it is in excess, so it will replace all the hydrogen. It will replace only the hydrogen. The double bond will be as it is. the double bond will be as it, and there will be no reaction with no reaction. Please do note.
Sir, what's written under KMNO4? SO.
A strong oxidizing agent, KMNO4 is an strong oxidizing. Let me know when you are done. Very good. Everyone done with this? See, if I'm going to give you this CH2 double bond CH, and if I'm going to ask you what will be the ozonolysis of the O3 in the presence of Zn and H2O. So what you need to do, just break the double bond and add O here and add O here. So it will be CH2 double bond O. 2 moles. That means basically it is an aldehyde like this. Yes or no? This is the scenario of ozonolysis. Do you remember ozonolysis? What you need to do, just break the double bond and add oxygen to that and to that, like this. I'm going to give you a short trick of this. This is your CH double bond, CH, and this is your double bond, and this is the scenario. So what you need to do, just break this bond. Break this bond, add oxygen to this with double bond, add oxygen to this with double bond. Then what you will be getting? You will be getting H H double bond O. Then double bond O. H. Is that clear, everyone? Yes or no?
Yes, sir.
Yes, sir.
Okay, so if I'm going to ask you a question about this, if you have CH3, then C double bond C, and then CH3, and then you have CH, wait a minute, and then CH. Can you do the ozonolysis of this O3 and then ZnH2O? ZnH2O, please write H2O, ZnH2O, not H2O2, because this will change our H2O. For time being, please write H2O, not H2O2. Can you write the product? What you need to do, just break this bond, add oxygen here, oxygen here. So what will be the left one product? You can see this will be the left product. And what about the right product? You can say C double bond O, H is here and C is 3. Is that clear? Is
Yes.
that clear? So if you are going to use O3, Zn and H2O, this will be the product. But if you are going to use O3 in the presence of H2O, please do write it after that. I will tell you. Let me know when you are done with this. Yeah, Adriel, Aditya, Hamza.
Done, sir.
So if you are going to use, let's take the first example, SCS3, CH3, and then double bond, then CH, and then CH. And if you are going to use O3 in the presence of H2O2, H2O, wait a minute, O3 in the presence of H2O, or either you can use O3 in the presence of H2O2, or either you can use hot KMnO4, or either you can use concentrated KMnO4. What will happen? Ozonolysis will take place in the same way. Ozonolysis will take place in the same way. See, this is your ketone, and the next one is your aldehyde. But this aldehyde will be further, I'm going to write it in a expanded form. This aldehyde will be further oxidized. This aldehyde will be further oxidized into carboxylic acid, ethanoic acid. Always remember that if you are going to use O3 in the presence of H2O2, sorry, O3 in the presence of Zn and H2O, you will get as it is, ketone or aldehyde. Either you will get ketone and aldehyde. And if you are going to use this O3 and H2O, or O3 or H2O2, or O3 or hot KMnO4, these are all oxidizing agents. These are all oxidizing agents. And what it will do, it will not oxidize ketone, but it can easily oxidize aldehyde. So whatever is the aldehyde form, you need to convert that aldehyde into carboxylic acid. So the main product, so the will be our main product will be this propanol